Now we're going to look at solving systems using the elimination method. The elimination method for solving systems of equation makes use of the addition principle. To eliminate a variable when adding, the terms containing that variable must be opposites. When solving using the elimination method, obtaining a false equation means there's no solution. When solving using the elimination method, obtaining a true equation means there is infinite number of solutions. So this is another algebraic method for solving systems. The elimination method, what you want to look for are opposite coefficients because you are literally going to add your two equations together. And what you hope happens when you add x plus x is 2x minus y plus y, what you want is for one of your variables to eliminate. So my y is eliminated, leaving me x in which I can solve for. So I got 7 for x. Now to find the y that goes with it, you simply substitute into one of your equations. I'm just going to use the bottom one, doesn't matter. 7 plus y equals 11. Subtract 7 from both sides, y equals 4. So my solution is 7, 4. And again, you can check that. This would be a really easy mental check. 7 minus 4 is 3, and 7 plus 4 is 11, so it checks out perfectly. Let's look at this system. Again, if we add, we get 12x, my y's eliminate, equals 14. Oops, sorry, 4. No, it'd be 14. Divide both sides by 12. I get x equals 14 twelfths. If I divide or reduce by 2, that's going to leave me 7 sixths for x. To find the y that goes along with it, I'm going to pick one of my equations. I'm just going to pick the top one. Again, it doesn't matter. And I'm going to substitute 7 sixths in for x. 6 times 7 sixths is simply 7. Minus 5y equals 18. Subtract 7 from both sides. I get 11. And finally divide by negative 5. I get negative 11 fifths. So my x is 7 sixths and my y is negative 11 fifths. And that would be my solution to the system. Now let's look at this one. We have x plus y equals negative 10, and we have 2x minus 5y equals 8. Now you can solve by substitution, like what we did in the last lesson, just by solving for x or y. Or in order to use elimination, we would actually have to multiply first. So the first thing you have to decide is which variable do you want to eliminate. If you want to eliminate the x's, and you already have 2x, then you want the top one to be negative 2. So you would multiply the top equation by negative 2. If you wanted to eliminate the y's, we already have a negative 5y, so we would need a positive 5y to make that happen. So we'd have to multiply everything by 5. Doesn't matter which one you want to do. I'm going to go ahead and multiply by 5 because I already have my opposite signs. I already have a plus and a minus, so that's the only reason why I picked that. But you could eliminate x's by multiplying everything by negative 2. This is going to give me a new equation of 5x plus 5y equals negative 50. This is a new equation, but it's still equivalent. And this one I don't have to do anything to, I'm just going to bring it over. Now I can eliminate my y's. 5x and 2x is 7x. Negative 50 plus 8 is a negative 42. Divide by 7. X equals negative 6. Now I have to find y, so I'm just going to pick the top one. So instead of x, I'm replacing that. Plus y equals negative 10. Add 6. y equals negative 4. So my solution is negative 6, negative 4. Let's look at one more. Again, I don't have anything that's going to eliminate, but one thing I do notice is that my system, or the equations, are kind of out of order. You want to make sure they are in the same format. So if you notice, the top equation is your x term, your y term, your equal sign, and your 5. So we need to, first things first, rewrite the second equation so that it matches the format of the first equation. So I need to get the y's over here, and I need to get my minus 10 over here. So, in order to do that, I'm going to add 10 to both sides. That's going to give me 6x equals 4y plus 10. And then I got to move my y over. And that's going to give me 6x minus 4y equals 10. Now it matches the format of my top equation. So I can bring my top equation over. I don't have to do anything to it. And now I can eliminate. Well, you'll notice that I don't have anything ready to eliminate. So let's just eliminate, how about the x's? So since my bottom is 6x, I have to multiply the top, because I need I'm going to need a negative 6, I'm going to have to multiply everything by negative 2. So that's going to give me a new equation of negative 6x plus 4y equals negative 10. Bring down my bottom equation of positive 6x, it's minus 4y, equals 10. Now I can add. My x's eliminate, so that gives me 0. My y's actually eliminate also, which this is strange. We haven't seen this happen before, so I end up with just a 0 on the left side. No variables, all gone. And negative 10 equals 10, that's also 0. So what has happened is my variables have eliminated, and I'm left with a true statement. What this means is these two equations are actually the same equation in disguise. So what this means is they have every single ordered pair in common because they're the same exact line. So this means we have infinite solutions. Had this same scenario happened and our variables canceled and we were left with a false statement, then we would have said no solution because they would have been parallel lines.